Welcome to this explainer. Today, we're unpacking a concept called getting found before you apply, the home lab architecture. Look, we're decoding something incredibly powerful here for ambitious tech enthusiasts, especially for those of you driving innovation right out of Kenya's Silicon Savannah. We're going to look at exactly how to build an accessible, cost-effective home lab that basically serves as your ultimate proof of work. All right, let's dive right in. So, how do you get hired without a resume? We're tackling that classic, incredibly frustrating paradox that almost everyone hits at the start of their career, right? The entry-level catch-22. You know the one. You need experience to get a job. But man, you need a job to actually get that experience. How are you supposed to break into the industry if literally every junior role demands 2 years of hands-on production experience? How do you prove your skills before someone even glances at your resume? Well, the answer lies right here in this specific desk setup. And hey, this isn't just some messy workspace, this is a carefully constructed architecture. What we're looking at is a cost-effective, professional-grade portfolio that is physically designed to get you noticed. It's the proof of work home lab. Let's tear down exactly how this setup works, piece by piece, so we can really understand the strategy behind the whole shebang. Now, when most folks start learning, they try to run all their virtual machines and containers on a single laptop. And you know what happens, right? You get a noisy, overheating machine that just crashes the second you try to open a web browser. Instead, this setup smartly divides the workload. It splits the environment into a dedicated management station for configuring and separate compute nodes for the heavy lifting. This mimics a real enterprise environment perfectly. Plus, it saves you from paying those massive cloud computing fees, which, let's be honest, is a huge advantage if you're building in regions where optimizing resources is absolutely key. Okay. Part 1, the management station. Let's take a look at the actual command center of this operation. For the management station, we're using a highly recognizable, ultra-reliable piece of hardware, a Lenovo ThinkPad. Now you might be wondering, why a ThinkPad instead of, say, a super sleek new MacBook or some flashy gaming laptop? Well, because ThinkPads are basically the beloved workhorses of the DevOps world. They are known for rugged durability and, honestly, most importantly, excellent Linux compatibility. When you're building infrastructure, you want a management station that just gets out of your way and works. Notice that little penguin sticker right there on the palm rest? That is a dead giveaway that this device is running a Linux distribution, and that's a highly deliberate choice. See, by using Linux as your daily driver, you build a real muscle memory with the exact same operating system and command line environment that you're going to encounter out there in professional server deployments. Moving on to part 2, dedicated compute nodes. Now we're getting into the real engine, tucked away just behind the laptop. So we call these things compute nodes. Basically, they are dedicated small form factor hardware units used in a lab to practice advanced concepts, things like clustering, load balancing, and high availability. By offloading your server tasks to these dedicated units, you get to practice complex enterprise networking right from your desk. And the best part? You do it without needing the massive budget required to rent cloud servers or rely on high bandwidth data centers. Having that localized power is just incredibly freeing. The really cool thing about the physical, stackable nature of these mini PCs is that it demonstrates a highly scalable, modular approach. Step 1, you set up the ThinkPad. Easy. Step 2, you add just one single mini PC to deploy your initial services. You don't have to buy everything at once. But as your skills grow, step 3, you grab a second mini PC, cluster them together, and boom, suddenly you're practicing high availability. The whole setup scales right alongside your own expertise. All right, part 3, orchestrating with Kubernetes. So you've got the hardware, but what kind of software actually unifies this whole system? The answer to that is in the KubeCraft branding and that cool little gear-like icon you can see there. That points directly to a focus on container orchestration. This home lab isn't built for clunky old virtual machines, no way. It is purposefully designed to run modern, containerized applications, leaning heavily into the Kubernetes ecosystem. Now, actually running full-blown enterprise Kubernetes on mini PCs can be incredibly resource-heavy. So to replicate this environment efficiently, you'd use lightweight container orchestration tools like K3s or Kind, which actually stands for Kubernetes in Docker. These tools are absolutely ideal for hosting Kubernetes clusters right on your home lab hardware. They give you a real-world enterprise API experience, perfectly tailored for the resources sitting right there on your desk. Which brings us to part 4, building in public. Because honestly, provisioning the hardware and deploying the software, that's really only half the battle. Think about it. If you build an amazing system, but literally nobody knows about it, does it actually help your career? Check out the Hacker News sticker proudly displayed right next to the trackpad. This represents a whole mindset.
It's about staying deeply connected to the broader tech community, reading what others are building, keeping up with industry trends, and most importantly, sharing your own projects and configurations publicly. And that brings us to the ultimate payoff of this entire architecture, the idea of being found before I applied. Just imagine having senior engineers and tech recruiters reaching out to you because they saw the complex infrastructure you were building and writing about on your own time. That is a real game changer.
So let's break down the ultimate goal here. The true purpose of this lab isn't just theoretical learning, and it's definitely not just passing a multiple choice certification exam. It's about creating real projects. It's about maintaining a public record of work, maybe through a tech blog or a GitHub repository. It's about proving your skills to potential mentors and employers with hard, tangible evidence. Essentially, it is a system perfectly designed to get you noticed before you ever even format a resume.
By combining an accessible Linux laptop, modular mini PCs, and lightweight tools like K3s or Kind, you've got the exact blueprint you need to start building your own proof of work today. And it works whether you're coding in Nairobi, New York, or literally anywhere in between. The architecture is proven. So, what will you orchestrate in your own lab?